Hi everybody. Today we're going to do lesson 8-4. Well, okay, and that is going to be called simplifying radicals. Okay, first thing you need to know, simplifying radicals, well, the simplifying part, you would have seen that when you simplified a fraction or put it in lowest terms. Okay, so say something like 2 over 4 becomes 1 over 2. They're equal. It's just one is simplified and the other isn't. The radical part is this symbol. Which you guys call a square root, right? Because the square root of 49 is 7. Let's see, the square root of 64 is 8. What's the square root of 50, though? Well, let's just remind ourselves of our factor pairs for perfect squares. So 1 times 1 equals 1, 2 times 2 equals 4, 3 times 3 equals 9, 4 times 4 equals 16, 5 times 5, 25, 6 times 6 is 36, 49, because it's 7 times 7, 8 times 8 equals 64, 9 times 9 equals 81, 10 times 10 equals 100. We're going to stop there for today anyway. Do you see how there's pairs of 1s to make a 1, pairs of 2s to make 4? We are going to be looking for pairs of numbers today. Okay, so we're going to take this square root of 50 and we're going to put it in simplest radical form. What it means is to take the 50 and we're going to break it down like prime factorization you might have done a long time ago. So 2 times 25 equals 50. Okay? Now, we're going to say, can I break the 2 down any further besides just a 1 times 2? And the answer is no. So this is what I call a bottom number. All right, now, the 25, can't we write it as a pair of 5s? 5 and 5. So that's a pair of 5s. Okay, so the square root of 25 is 5, so that goes on the outside because we're able to take the square root of that piece. The 2 we cannot take the square root of. That stays on the inside of the radical sign. So pairs go out and singles stay in. Doesn't seem fair, but that's the way it goes. Okay, so that was example 1. Okay, let's do example 2. Sorry, I'm going to pull it over to here. All right, example 2. Square root of 18. Okay, so two numbers that multiply to be 18. Well, any even number is divisible by 2, so that's a good place to start. 2 times 9. Now look at this. This is a bottom number because we can't break down 2 anymore. But look, 9 could be broken down to a pair of 3s. Pairs go outside the radical sign, then make the radical sign, and the 2 goes in. 2 is a single. So square root of 18 is equal to 3 square root of 2. Just the way square root of 50 or the radical 50, it's not really square root, is radical 50 is equal to 5 radical 2. All right, example 3. Square root of 200. Oh, you know what? I'm going to clear this off and make some space. One sec. Oh, magic. I might as well clear the rest of it. All right. So this is going to be number 3. I'm going to do number 3 2 different ways because you can. And I don't want anybody to think that there's only one right way. So example 3 is radical 200. I'm going to break this down into what's called simplest radical form. Well, I usually start with a 2 if it's an even number, so 2 times 100. And if I was doing prime factorization, I would do 2 times 50, 2 times 25, and 5 times 5. Okay, now you have pairs. You have a pair of 5s and you have a pair of 2s. So pair of 5s comes out as 1 pair, 1 5, not 15, 5 times the other pair, which is a 2. Look what's left over. Square root of 2 goes on the inside. So we have a pair of 2s we put on the outside. We have a pair of 5s we put on the outside. What's left over on these bottom numbers was a single 2. It wasn't a pair. Therefore, our answer is 10 radical 2. Okay? But I said I'm going to do this 2 different ways. I also said watch out for pairs. So radical 200. If I break this down, I get 2 times 100, just like I did. Can you think of a pair of numbers that multiplies to be 100? Well, hopefully you can think of the pair 10 times 10. So I could break this 100 into 10 times 10, and I can stop there. It's a pair. I don't have to break each one of them into 2 times 5, 2 times 5. You can. It's not necessary, though. You stop when you have pairs. All right, so I have a pair of 10s. That comes out as a 10. What's left over is a 2. Okay, so the 2 goes on the inside. Look how many steps I saved just by looking for a pair as opposed to breaking it all the way down to prime factors. Again, either way works. Do what works for you. Let me see. I'm going to do one more problem. I'll just move this down. Let's see. Example 4. Okay. Square root of 48. Again, it's an even number. 2 times 24. Okay, now I could divide by 2, or I could divide by 4. Let's just break it down by 2. This one I think most people would just break down by 2. So this is 2 times 12. 2 times 6 equals 12. 2 times 3 equals 6. Now, our bottom numbers have pairs of 2s. This is a bottom. Pairs of 2s. Another pair of 2. And then the 3 is by itself. The 3 goes in under the radical sign, and the 2 pairs of 2s come out as 2 times 2, which is 4. So it's 4 radical 3. Could I do it a different way? Sure. I could have done 4 times 6 for 12 and then gotten 2 times 2. Either or. Each way is correct. So this is what I want you to remember, though. Just because you learned this new way, you still have to remember something like the square root of 36. You don't have to break this down. I mean, if you broke it down, you'd want a pair. 6 times 6. A pair of 6s goes out. But really, the square root of 36 is just 6. Square root of 100 is just 10. So you don't want to be breaking down the perfect square. So your first step really is to look to see if it's a perfect square or not. Okay, if it is, take the square root of it. If it's not, you have to break this down into simplest radical form. All right, I'm going to give you a couple to try. We'll do some more tomorrow, a couple more involved problems. Okay, so here are your 4 problems to try on your own. So hit pause, try them out. When you're done, hit play, and I'll have the answers up for you. Okay, so here are my answers. First is 2 radical 2. Second is 2 radical 10. I showed you 2 ways you could have gotten it. 3 is 3 radical 10. I showed you 2 ways you could have gotten it. 4 is 9 radical 2. There's another way you could have gotten it, but I'm hoping this is the way most people would have done it. So that's it. That's simplifying radicals. We'll do some more tomorrow just for more practice. Have a good day.